So for motivation, consider these images. So here we have two identical images on the left, and on the image at the top we applied an 11x11 Gaussian filter with sigma equal to 100. So since we use a very large sigma, I mean it doesn't capture the Gaussianness of the filter, so it would be roughly close to applying an average filter. But the particular method, whether we are using average filter or a Gaussian filter, is irrelevant for this discussion. What we want to show is that if we apply the naive image smoothing filters, they are going to blur the images. You can see the boundaries have been blurred out over here. Likewise, we have blurred the boundaries and image is blurred, but we also lost all the boundary information. So here we had road boundary information, we have completely lost it over here. This region has become homogeneous, but the boundary has become very large, and likewise on the left we have lost tremendous amount of boundary information. Now you can see the transition even within the windshield and the car boundary, the transition is not very clear. At the bottom we have a filter. We don't care about the exact details of the filter, but we applied one such filter which uses two Gaussian components. So it uses a special Gaussian, just like in the regular Gaussian filtering, and also uses a Gaussian filter in the color space, and we will discuss what this filter is. So here we applied one such filter that smoothes out the images but preserves the edges. So you can see there was a lot of texture in the road region, and after smoothing the texture has been lost. Most of the texture has been lost. Even within this car, you can see a lot of shininess has been removed, but we have even here we have preserved this edge. So here also you can see that a lot of information has been removed as a result of smoothing, but we have preserved the sharp transition, the boundary information. Likewise over here as well, you can see we have removed the details, the texturedness present on the road due to shadows, but the boundaries are still sharp. Whereas on the image at the top, we have lost all the details of the obstacles. So if the goal of our algorithm was to detect both the road and obstacles, this blurred image is now sort of impractical for any use in the obstacle detection, for detecting obstacles that are far away from a vehicle. Whereas in this image, we can still detect obstacles and can detect roads as well. So this is an example. Consider another example. So all these images were again captured using the cameras mounted on our autonomous driving vehicle. Here also you can see at the top we again filtered this image with a Gaussian filter. You can see we have lost the sharp transition between the road and non-road. All the boundaries have been blurred. Whereas here we have smoothed out the image, but the boundaries are preserved. There's some loss of boundary information over here, so it is not sharp as this, but anyway, any smoothing filter is going to have some blurriness into it at boundaries, but you can see most of the sharp transition have been preserved. So this is the motivation for filters that smooth out the images but preserve the edges in images. So we'll discuss two such filters. One is a bilateral filter and the other is Quora. And just to let you know, here we have smoothed the image with a bilateral filter, and here we have used a regular Gaussian. Here also we have filtered the image with bilateral filter, and here at the top we have used a regular Gaussian. So in the next few lectures we will discuss mathematically both the bilateral filter and the Quora filter.